Before I tear down my engine, I want to figure out how the engine volume is calculated. Before I begin to disassemble the engine, I need to take a couple measurements of the cylinder bore and the depth, which in other words, the stroke of the engine, or at least in my head, that's the way I'm envisioning it. So I'm going to take a few dimensions before I tear it down, because once I tear it down, then I can always measure the bore diameter, but then once I remove a piston, I won't have the opportunity to measure the stroke of the piston. So I'm going to go take some measurements now, and then I'll come back to the drawing board and do a few calculations. Okay, so I'm using a large screwdriver in the slot at the end of the crankshaft in order to find top dead center of this piston here, and I'm rotating it just until it starts to draw right there. So right there, top dead center, best I can get. Okay, with this piston at top dead center as best I can get it, I am going to make a couple measurements. One is I'm going to measure the diameter of the bore, and I'm going to measure the depth all the way down, since that piston's at the bottom. I'll measure the depth from the top all the way down. And the bore diameter, I will measure both. I'll measure these two pistons at just varying angles, just to see what I get. So, bore diameter, 2.82, 2.82, 2.8, 2.81. I'm going to measure that one again. 2.815, 2.81, 2.825, 2.82, 2.817. All right, so I'm going to write this down. I'm just going to take a mental average that the diameter is 2.82. Now to measure the depth. 3.26, 3.235, 3.25, 3.25. All right, so I'm going to write down 3.25 as the depth. With any math problem, you always start with what you know. So, we're going to treat my bore like a cylinder, which it is. And the volume of a cylinder equals pi r squared h, where pi equals 3.142, and it's unitless, there are no units. R equals bore diameter divided by 2. R is the radius of the cylinder, right? R is the radius of the cylinder, so it's a diameter divided by 2. And H is the height of the cylinder. So that's going to represent our stroke. Now from my measurements, my bore diameter was 2.82 inches divided by 2. That is equal to 1.41 inches. And then when you convert that to millimeters, you multiply by 25.4, you're going to get 35.81 millimeters. The stroke, I measured it out to be 3.25 inches. You convert that to millimeters, you multiply by 25.4, you're going to get 82.55 millimeters. Now my whiteboard is small, so I'm going to have to erase this and start over. So I'm going to write these numbers down, and then we'll kind of start over. Therefore, my volume of my cylinder is 3.142 times R, which is 35.81 millimeters squared, times the stroke, which was 82.55 millimeters. That's going to equal 332,607.40 millimeters cubed. That's unitless, millimeters squared times millimeters cubed. Now I need to convert that. Most engines are in cubic centimeters, so I need to convert millimeters cubed. There's 10 millimeters per centimeter, so 10 cubed is 1,000. So you divide that by 1,000, and you get 332.607. 607 cubic centimeters. So the volume of one cylinder is equal to 332.61 cubic centimeters. There are 4 cylinders, so 4 times 332.61, that's equal to 1330.4 cubic centimeters. All right, so we have just confirmed that my engine is actually plus 0.06. All right, so with simple math, I have just calculated my engine size, and I just proved that indeed it's a 1330 engine with 0.06 oversized pistons in it. So I'm very pleased now that I know how the volume is calculated, and I can calculate any of the engines, right, with the same method. Now, I have picked up this book. This book was recommended to me by Rich Allen with Mini Performance. I have a couple Haynes manuals, and they give some of the same information, but they give, for all the stock engines, they give the bore diameter in millimeters, and they also give the stroke in millimeters. So you can start from that point, in which I'm going to go inside right now, and I'm going to do the math. I'm going to start with the stock 1275. I'm going to add 2,000s, 4,000s, 6,000s, and see if I get the same numbers, or, you know, right at it. I'm very pleased that I got 1330 first go around, first try. I'm right there. So now I know how the engine capacity, the engine volume is calculated, and I'm very pleased. So anyhow, yeah, my next step now is to actually start tearing down the engine block and remove all the components, remove the pistons, remove everything, and I will hopefully do that this weekend. Thanks for checking in, and all right, bye just now.